So here we are today trying to see if DeepSeek model can be or how can it be used in the Agentic AI development framework. Agentic AI is the main theme of 2025 for many research groups as well as companies trying to adopt generative AI to their workflow. Don't forget to give us likes, leave your comments, share us to your friends, and also subscribe to our channels. We have YouTube, LinkedIn, TikTok, and Facebook. And the framework that I chose to demo today is smolagents from the Hugging Face team. The reason I picked this is that this agentic framework is small, simple, and if you want to develop a small specific scope application, this is I think I would love to use this one to get started and prove your concepts rather than spending hours to actually develop some hardcore agentic framework like LangGraph, for example. The small framework actually allows you to create multi-step agent that actually will keep going into subtasks until the main task is done. That's the multi-step agent, but also allows you to do multi-agent system where multiple agents talk together and work to solve a bigger task given. But I'm not going to talk about the whole framework of small agent framework today. So please stay tuned for an episode dedicated to this topic. Sign up, click subscribe, and you'll get a notification when this episode is ready. But I will actually give you a quick demo of how this is going to be and how DeepSeek model fits into this one. All right, so I have actually prepared 3 versions because I wanted to compare the performance of the small DeepSeek model, the 1.5 billion parameter, to a medium size 14 billion parameter size, and you can see that you need to pick a large model because agentic framework requires model to think and reason well. And lastly, as a benchmark, because we all know that the GPT-4o-mini is capable of function calling and reasoning enough for me, it's enough to do some simple agentic framework. All right, so let's actually get you to see the good performance of a good model, the GPT-4o. All right, so let me actually restart the session here. This is importing stuff and you don't need to focus a lot here, but again, the agent is going to be created by the code agent. Code agent is a way that the Hugging Face team design its agent to be. The agent wouldn't understand tasks and can write code and execute the code, and that's the essence of it. So let me just load that up, and this is going to initialize the model instance talking to API over to OpenAI server, and we call the GPT-4o-mini for use here. Now we actually create an agent with the code agent, provide the model that we want to use, and you equip the agent with the Python interpreter tool. And that's pretty much it. And we will allow the agent to do the task at maximum only 3 steps. So the task that I'll show you today here is to calculate a math. And this is what's the log of 10 to the exponential of 20? If you know math, the answer is 20, right away. But in agentic framework, we know that LLM itself can hallucinate, especially when it needs to deal with math calculation. So the agentic framework promises you that the agent will know to call a calculator tool to solve a math problem. All right, so the correct way for the model to do this task is to actually call the Python interpreter tool and code so that it can solve this expression. All right, this is the query. Now I am going to send the query to the agent, and the agent has a brain of the GPT-4o mini. Okay, now we see that, oh, step 1, I need to write this code. But look at that. It uses its own knowledge. Maybe this question to eat for it, and the answer is correct. So this is not illustrating my point. So let me just tweak the number a little bit to make it a little bit harder. Now, when it's not as simple, it should be actually triggering the tool. Right now, it's actually trying to write code to solve that particular problem because the question requires you to actually use a calculator now. And the answer is 0.2. I think this is right. You know what? Maybe I will embarrass myself. Let me just do that over here. But let me just import that and math log 10 of 20. That's what I want, right? Oh, am I going to embarrass myself here? Oops. Oh, come on. Is it a log? Am I doing the right thing? Okay. Okay, now the answer that it gives me is 6.2, 6.02. Am I doing something wrong here? A log of 2 to the 20. See, I am embarrassing myself. Oh my god, this is interesting challenge. You know what? Let me cheat a little bit. Instead of 4o mini, let me use 4o. Instead, the query is still the same. Log 2 to the 20. And let me run this. Oh, wait, hold on. Why is it still 4o mini? Oh, my bad. I need to reinitialize agent. Something is strange. Let me just interrupt. Okay, let me try it again. 4o and create my agent. And this is the same query and run. Maybe this is overflowing. Okay, let me just reduce the number. Let's do 2. Maybe 2 is too much. Yeah, I think it's too big. So the math ground truth is, oh, come on. What is happening? Domain error. Oh, my bad. See, I'm embarrassing myself. Okay, we need to be able to get to log of 2 to the power of 2, okay? And the model gives me answer of 0.602, which is the right one here. Okay, so I actually figure out that 2 to the power 20 is probably too big for the float system that we have. Now, you can see that the model write the code well and execute the number for us, and that's the response, right? When you actually print the response is that. All right, so this is the power of GPT-4o, and if we actually go back to the mini, I think it should have the same answer. We are now running the same math problem with GPT-4o mini, log of 2 to the power of 2, which is log of 4, right? Now it actually does some, I don't know why it needs to do some logic here, but the answer is still 0.602, according to what we see before. All right, now we know that, okay, this is the performance of the GPT-4o and 4o mini. Now let's actually experiment or try with the DeepSeek-R1 14 billion parameter on my local computer. So let me refresh the kernel. Now import my stuff, initialize a model. Now you notice that this is the 14 billion parameter of DeepSeek-R1 model. Then we'll give it a same query. Now we hit the agent, right? The agent now is thinking. Now it has, just to remind you, DeepSeek-R1 has a thinking ability, and it will think its way through to the final answer. Now I think this is thinking was taking quite long to finish. Step 1 is taking so long. While we are waiting for that, let me actually just update this to be the same as previous other models. Now it's actually quite long, so let me actually check if it's running. Right, it's running. The reason can be that there are many rounds of models communicating. One thing about agentic workflow is that it usually takes a lot of tokens, and that's because there's an underlying orchestration layer, a lot of prompting in there. Therefore, you are likely to consume a lot of tokens compared to just a single pass LLM. Now, with the 14 billion parameter, and you can see that it made some error, and this error is likely to be because the way it's actually working its way through is not in the right syntax for the output parser to do it correctly. As you can see here, the error is happening because inside the code parsing, right? And that's related to the orchestration layer, because there is going to be a protocol of the parser of one agent output to the other. It is actually taking quite long. Now, step one, it has failed. Step one, it has failed because it has encountered an error. Now it entered the stage number 2, where it's trying to compute again with this code, and somehow this is right, and it has the answer 6.602 as we have before. Yep, that's much the capability of the 14 billion parameter. Well, you have to give it some credit. It's a small model, and the fact that it can actually arrive at this point after 3 steps, it's good. The way you're running this model locally, so yeah, it's not too bad. So let's actually try the smallest one, the 1.5 billion. Actually, I want to interrupt the model here because it's taking too long now. Okay, now we are back to the 1.5 billion parameter, and I think what we'll see here is that it's going to make a lot of errors. Now, I created an agent instance with the 1.5 billion parameter DeepSeek model. The step number 1, it just gave me a code without any import or anything. That's why it ran into can't import a function. Yeah, interpreter error, not permitted to evaluate other functions with the provided tools. It also ran into the problem again. This is syntax related, and parsing error. So all of the 3 steps that it has a chance to fix or solve the problem, it failed. And you are not going to get any response. You are just going to get the way it thinks, right? The reason is that the model is too small to have a good reasoning ability to solve this task. The agentic task is quite difficult. And one thing that I want you to take a look here is that all the mistakes that it has done before, it's inserted as a context. And that's why you are consuming more and more input tokens as the agent struggles the task. And that's one of the costs that a lot of agentic system is getting expensive, because when error happens, everything is used as a context for the agent trying to solve itself.